and I did not find a job when I graduated in engineering. The only job I found was a lab engineer in a ready-mix plant in Abu Dhabi in the United Arab Emirates. And I did not know anything about concrete. We took a course of an hour in the engineering faculty in Lebanon, and they told us concrete mix is 1, 2, 4, 1 sack of cement, 2 sacks of aggregates, 2 sacks of sand, 4 sacks of aggregates, and some water, and you check the water visually, and this is the concrete mix. I went to Abu Dhabi, and there was an air base. In the ready-mix company, I was the only engineer coming to this company, so they thought I was the biggest knowledgeable expert in concrete. And they said, we want to do a mixed design for an air base. And that mixed design should have 30 MPa at that time. And it should be pumpable. This was in 1985, and pumpability was a big thing. So I knew nothing, and it was either telling the people that hired me that I knew nothing, or trying to do something about it. And they said, look, there are some books here in the corner. Try to use them if you need, but we need to submit the mixed design tomorrow. So I looked at one of the books, and there was a chart taken from NACI 304 on pumpability, showing a combined grading curve on aggregate. That chart saved my life, saved my job. I used the chart. Second day, we submitted the mixed design. The client accepted based on trials. We did the trials. They went perfect. We got very good results. After 7 days, 28 days, a month later, I became the expert in mixed design in the firm. And 6 months later, I became the mixed design expert in Abu Dhabi. So all this to tell you that one chart from ACI made me get the job and continue with it. And so many other things in ACI helped me in my career. And so my message is, if you look at ACI, there is something that will give you an edge, a competitive edge that people might not have it. It's a very competitive market out there for us engineers and people working in concrete. And to really find the edge is not something easy. And so that's why I think ACI is a good source of knowledge and a good platform to get your professional edge. So what is ACI? It's a technical and educational society dedicated to improving design, construction, maintenance, and repair. So it's one of the world's largest sources of concrete knowledge. The members are architects, consultants, contractors. We even have lawyers, insurance brokers, people who come from different trades. Mostly it's from people in the concrete industry. But frankly, for anyone interested in concrete, ACI develops and produces more than 400 technical documents, codes, the ACI 318 building code. It's a big reference in most of the projects in India as well. Specifications, reports and guides, references, and the annual manual of concrete practice, which is now called ACI Collection. ACI has also certification programs, and I'll talk about it in a while, what we are doing with the certification programs in India. So we have different grades of programs. You have the field testing technician. This is the most popular one. Flat work finisher, strength technician, aggregate technician, and adhesive anchor installer. So more than 22 different programs for different trades. We have also online learning modules in what we call the ACI University, where you can go and look at any seminar of a topic that you like or you are interested in. And these actually are supported by the technical committee documents, the certification, and general education. These are the actual training modules that go along with all the other products of ACI. So what's happening new in ACI? We have a new category. If you are a member of the ACI chapter, India chapter, you become automatically a member of ACI International. And you get a lot of benefits that you wouldn't get otherwise. So you have access to, but they really don't know what these are. And we thought that maybe ACI is very good at doing, the library job. We build documents. We can make the best library in the world. But how are we sure that people are using this library? This knowledge is actually transferred to practice. This knowledge is actually being used the way it should be, because it is state of the art and really coming from experienced people who spend a lot of time in research and technical and practical experience, and bring this to ACI to develop the code, which is a consensus code. So if you're in a room, everybody should agree on any statement, on every word. And if you ever went to an ACI committee, you would understand that this is not an easy process. So ACI changed the mission from developing and disseminating consensus-based knowledge to actually developing, disseminating, and advancing the adoption of consensus-based knowledge it's developing. And this is a major thing. So ACI is now having the responsibility to go and make sure that this document or this information is used the right way. So just to summarize about ACI, I have a small video that tells you how you can be involved in ACI and why you should be part of ACI.
Not everyone in our industry is a member of ACI. Just the ones who are pushing the concrete community further, adapting to new technology, investing in their careers, and dedicated to improving their design, materials, and construction. Those who are pursuing an education and teaching the next generation. Those who want to not only find more work, but do it better. Those who want to be part of a worldwide community of professionals, educators, and students in more than 100 countries. Those who want to meet the experts and become the experts. Those who want to stay on top of the latest techniques and create new ones. Those who believe you can never learn enough. Who make sure things are done right the first time. Those who want to be the one others go to for answers on the job site. And those who want to create amazing things. You don't have to be an ACI member to work in the concrete industry, but if you want to exceed expectations in it, there's no better place to be. Whether you're a student just starting out or have years under your belt, ACI membership ensures that no matter what changes the world brings, you will be prepared to thrive, and your life's work will last for generations. Join us today at concrete.org.
So now you know where to go to get your ACI membership. Just go to the ACI India chapter and you can get your ACI international membership there. Lost my... So going back to the large-scale projects and what we initially said about what's happening in India, and I'll bring you the perspective of the Middle East and the projects that we've been involved in. My company is Advanced Construction Technology Services. It was established in 1996, and it's a third-party provider for geotechnical engineering, materials testing, consulting, and we also do the certification programs for ACI in the region. We also represent different standard developing organization and information management systems. So we sell standards on behalf of IHS, IEEE, and ASTM. We started in 3 countries. We started in one country in Lebanon initially. This was the underground garage that I had, and then we started there, and then we developed into a regional operation. In 2011, we were still 3 countries, and now we're 10. And I'd like to announce that we'll be soon in India. So we have finalized a partnership with Durocrete Engineering Services in Pune with Mr. Ujwal Kunte, and we will be hopefully operating in Pune with him and throughout India as well very soon. So India will be our next addition before the end of the year. So these are the services that we do: materials testing, technical standards and solutions, geotechnical engineering, training and certification, environmental testing, durability and service life assessment, and this is becoming a hot thing. How do you know that your concrete is going to live for a certain number of years? People tell you that they want 50 years and 100 years. How do you show that? Structural health monitoring, how to actually monitor your bridges, your assets, your metros, and make sure that you have enough indication about preventative maintenance in time before there is closure or there is a breakdown or there is even an accident. We do concrete technology consultancy on different aspects of concrete technology. We do NDT on metallurgy and testing and welding and inspection and testing. And we do fire engineering. We started our fire lab in Khobar in Saudi Arabia and it's now online. So we will be having our first fire testing results for the first project is a hospital in Saudi Arabia very soon. And we're involved in one of the world's largest projects because these projects happen in the Middle East. So, you all know about Dubai Burj Khalifa, which is 800 meter. There's another one in Jeddah, which is 1,000 meter. I'll be talking about that. One of the biggest airports is being built in Jeddah. The biggest metro is in Riyadh. There are 7 stadiums that we're involved in Qatar. So even in Lebanon, where, it's a very tiny country, we're starting to talk about 200-meter buildings, 70 MPa concrete, 500,000 cubic meter of concrete in a waterfront city. So from Lebanon to Doha to Saudi Arabia to Kuwait, we have the International Airport of Kuwait, which is a very sophisticated design by Foster that really challenges any concrete expert. And all what you think about concrete, all what you've heard about in the last 2 days is already in this project. So you have to actually experiment what we've been talking about. And the new Doha Airport, the Doha Metro project, as I said, we have the stadiums that are currently under construction, 7 stadiums. We are involved in 7 out of 8 stadiums there. The Riyadh Metro project is still under construction. It's a huge project. It's around $30 billion project that has 6 lines. We're involved in 2 lines in a full-scale engagement in the other lines in different services. The one I want to talk about is the one that really opened our eyes. This started in 2011, I think, and into large-scale projects. It's the King Abdulaziz International Airport in Jeddah, where we really learned what scale means. And I'll talk about it in a second. So in Jeddah also there is the Kingdom Tower project. I'll be talking about it in detail, and the Haramain high-speed rail, which is connecting different cities and also connecting the new airport. But let me talk about the airport by itself. So the total volume of cubic meter for this project is 6 million cubic meter. And initially it was designed to be finished in 4 years. We're in the 6th year now, and I think we need another year to complete. So this is the phase 1. This is 30 million passengers for phase 1, and there is another phase 2 that didn't start yet, of course. So it involves a multi-story car park, railway stations, automatic people mover, and there's also a road network around it, which is around 20 kilometers with an expressway and, of course, the aprons and taxiways and tunnels. So in the construction stages, we started with piling and footing works, raft foundations with mass concrete. And you can see the volumes even for piles, which was around 500,000 cubic meter. You had raft foundations with 1.2 million cubic meter. Self-compacting concrete around 60,000 cubic meter for the arches. Roads and bridges around 1 million cubic meter. And they started, and we're completing them as we speak. Passenger terminal building, 1.5 million cubic meter. And air traffic control tower, small one, but very, very difficult in terms of the concrete strength and the fairface and all what they needed with this. The fire fighting building and the rescue center, around 50,000 cubic meter, and the high-speed railway is around another 500,000 cubic meter. There's also the automatic people mover, APM, which is 220,000 cubic meter. And each one has a different requirement in terms of inspection, concrete grade, testing, early age, long-term strength, and long-term durability. The taxiways and the aprons also have different requirements. So just to give you an idea of scale, this is 5.3 million cubic meter when I did this presentation, and we reach around 200,000 cubic meter per month, which is quite an intensive scale given the specifications and given what's required in terms of testing. And we had 35 mixed design to do there. And it's not just 2 per month at all batching plants. And again, this is the total tests on aggregates around 200,000 plus tests. The concrete specimens, we reached 1,500 cylinders per day, some of them taken for compressive strength, some of them taken for durability. The chloride permeability, the absorption, all these tests were done also in parallel. So the scale is really staggering. And when you have something like this, you cannot manage it the way we used to do a few years back with papers. You need systems. You need management systems that take care of that. Otherwise, it's impossible. It's just not. It's not a luxury to have a system. It's a need and requirement. And once you start implementing the system, you see that you have a better way to manage the project, not just to give the information quickly and to have, rapid access to the information, but in the input you can have. You can start having statistical analysis, understand trends in the concrete development program, understand the mixed design fluctuations, and then how it's coming from the batching plant or from the actual site. So all this information can only be done when you have proper systems implemented. So let me focus on the 1 kilometer Kingdom Tower in Jeddah. So the project is aiming to become the tallest building in the world, 1,004 meters, so around 176 meters higher than Burj Khalifa. And the design was made by the Chicago-based Adrian Smith and Gill and Thornton Tomasetti for the structural engineering. And they did also, Thornton Tomasetti did the structural engineering design for the Burj Khalifa project. So initially what you do when you have a project like this, you grout the ground. So you just inject grout to make sure you fill all the cavities even before you start the piling. And you really reinforce your ground before you do anything with the grouting. And then you had 270 piles between 1.5 to 1.8 meter in diameter, and the length was varying between 45 meter and 105 meter. So the biggest piling machine was on this project to be able to do this kind of project of pile size. Then it was followed by raft foundation, 5 meter thickness. Yesterday we heard about mass concrete. This is typical mass concrete. Remember, Jeddah in summer is at least 45 degrees in the shade and 100% relative humidity, and this is what we had to deal with. And the raft foundation happened in August, so that's another challenge that we had to work with. Even the core walls were 1.8 meter thick. You think that mass concrete is mostly, raft foundations. It is actually, in this case, it was even the core wall of the building. And even other elements in the podium and other columns were challenging. So we are now at level 64. The project has its own issues because of some internal issues in Saudi. But the ultimate goal is to reach 266 floors, so 202 remaining floors. As I said, Jeddah is not tolerant weather. It is hot, humid. Even in the winter, we get this sandstorm or this rain, which is very aggressive for half an hour and just spoils everything around it. So this type of weather, it brings all the challenges that you would think of. You have to design and place high-strength concrete and high-performance concrete and mass elements, the raft, the thick core walls. You have to make sure that your finishing is adequate and curing is adequate for the flat work placing operations. And you have to always ensure there is continuous protection of concrete. Add to this issue the wind. The design, the structural design of this project is based on wind. And not only the wind is a critical factor in the structural design, but it's also a critical factor in the construction, because you have to start dealing with wind when you're building, when you're doing the core wall and building the slabs at the 60 and 70 and 80 floor level. So you have to have wind breaks, you have to make sure that everything is protected and your own laborers and the workers are protected. The other challenge is that you have to pump concrete up. So concrete should be pumped up to 860 meter, I think. And this is something that was undone before. So it is completely uncharted territory. How do you pump concrete there? So we decided with the Schwing to do a double stage pumping. So we'll pump up to the 520 meter, and then we'll have another pump installed at the 520 meter and pump upward from there. And at the same time, the designer will ask you for a modulus of elasticity. They will ask you for strength and durability and concrete at 800 meter. So no fresh properties specifications. They need these hardened properties, and then you have to develop, because no one can tell you what fresh properties are needed. So they will tell you, I need a high slump or a high flow or whatever, but then you have to really start working into developing a mixed design program that addresses the structural requirements and durability requirements, but also you want the concrete to be on the top, to be able to be placeable and finished properly, and that doesn't give you problems. Again, like we did at the Jeddah airport, we could not do something like this without a very tight loop on between quality control and testing. These become integrated functions in a project of that nature. So for example, when you do the mass concrete, what you think of is reducing the concrete fresh temperature, making sure that you have thermocouples installed in the raft. The differential temperature does not exceed 25 degrees. The initial temperature does not exceed 75 degrees. All these things are there. But as a QC, to help this, you have to do mock-ups and to do the insulation properly. So you have to actually insulate the raft foundation, and not just insulate it, understand what is the thickness of the right foam insulation that is adequate for this raft. And all this has been done in a mock-up. We reached, for example, that the best conclusion was to have a 7 centimeter insulation foam on the raft foundation to make sure that the concrete and the mass is actually going at the same, with a minimum differential to reduce thermal stresses. So I'll give you some of the QC highlights. As I said, you integrate testing, quality control, inspection, mixed design development. These become integrated functions. They are not separate functions when you have projects of that nature. So you start from the assessment of the materials, the aggregates, the sand, the cement. You go to the mixed design development, then back to the quality control inspection, making sure that the batching plant can deliver what you actually designed. You even go and check the formwork, because you have hydrostatic pressure that comes on the formwork because of the fluidity of the concrete. Then you go to the field testing, you monitor the site, post-placement, pre-placement, you do the inspection, and then you do the evaluation of the hardened concrete testing. So the first thing we did is we established a site laboratory. This is something we couldn't manage from. Even our lab was maybe less than 50 kilometers away from that project. We had to establish a site lab with a dedicated team. We built 5,000 kilonewton machines. We are going to test concrete of 100 MPa plus. We want to make sure the machines can handle that over the time. The same way for the modulus of elasticity. We developed a very tight QC program, and also the challenge we took is we wanted to minimize repair. So we told the contractor, our promise is to make your repair cost related to concrete placing and construction zero during construction. And we also established an online system to manage all this information. And the other challenge that we had the project manager in London, and they wanted to access all the information real time. We had the designers in Chicago, and we had the people in Saudi Arabia. We had the main office of the client in Riyadh and the project in Jeddah. So you had multi-stakeholder locations that you had to also give access to for the information. And this is, as I said, uncharted project, so people are interested to understand what's going on step by step. This is more than $1.5 billion project. So we started with the raft foundation with 70 MPa concrete and did the QC, as I said, on the insulation side. We made sure that all our equipment that could be integrated with our laboratory management information system, or the LIMS, can directly give the information to the system. So minimum worker involvement in writing results. So the result comes from the crushing directly to the database, and the database will issue the report as soon as they receive the result. And not only that, we have all this information stored in the cloud and accessed by all the different stakeholders. So we had our LIMS installed on the project and made sure that we have the archive and the access and the real-time access to the testing information and to the trends also available. So people could actually access test results online, and not just the hardened concrete testing, even the fresh concrete testing. All our technicians and engineers were having their iPads and tabs to log the information as soon as it comes, so people can have access to this information. So slump flow, V-funnel, all the information was logged real time through tabs and sent to our LIMS automatically. And we have all the online applications that we have developed, especially to manage this project for the pouring system, so we understand how many concrete is being poured, how many concrete is on each pump, how many concrete is at the batching plant, how many trucks are at the batching plant, how many trucks are on the way. When the trucks come, where do they go, on which pump they should go first, and whether we should keep one pump or take it out. All this was managed at the pre-construction, and we developed a system for that, which was really running perfectly for the contractor, especially when you are in August and the ambient temperature is above 45. So your tolerance for delays is practically zero. And all the thermochrome, the thermocouples, you heard about it yesterday in the presentation, that were installed were also linked with our LIMS and our information system, so everybody could see the concrete temperature, the fresh concrete temperature through the tabs, through the direct log of the information, and also the thermocouple information being backed up to the system. So we took slump flow, T50, J-ring, all these SCC tests that you normally do for the self-compacting, self-consolidating concrete. We took these tests and we also logged them live. And visual stability index, all this information was uploaded online as we did the test. And again, the monitoring system was important to check the trucks and the flow of the concrete on the pump to make sure that we maintain a proper flow to avoid cold joints in the raft foundation and even in the core walls. And the truck monitoring system with GPS on the trucks, and also giving the GPS information to the truck monitoring system so we understand which truck is going to come, and if there is a delay, what's the reason of the delay so the driver cannot stop on the way or something. Everything was managed to make sure that the concrete flow is consistently regular. And this is, again, for the pump allocation and how we actually use the system to know which pump should have more trucks and where do the trucks come when they arrive to the site. Normally what you do that, you check the pump. If there is no truck there, you send the first truck there. Well, in this case, we had to really manage it in a different way to make sure that the raft foundation is being filled properly. And the thermocouples we used are all digital, so we could have this information digitally transferred to our online system. So in a project like this, you know, as I said, you have the hardened concrete properties that you know how to deal with. You do the mixed design for strength, for slump flow possibly. And you have different grades. We have 30, 40, 50, 60, 65, 75, and 100 MPa grades. It's much better than the airport project where we had more than 30. But even for the blinding, they used 30 MPa concrete. So there was an obsession of making sure everything is safe, everything is structurally right. But at the same time, it was our responsibility to make it economical for the contractor, because you can throw anything you want on the mixed design, but if the contractor doesn't approve the cost, nothing will happen. So we had to really use optimization techniques to get the mix to be economically feasible. The C40 and 50 were used for the slabs and the podium elements. And again, there you had normal concrete, 40, 50 MPa. So when you look at the mixes, this is the high strength requirements. And you see on the right that this is mostly the consultant and the contractor requirements. So the strength, durability, cost, the MOE, it should be pumpable, and it should develop a certain strength within time. So you don't want a strength that comes after 180 days or something, because this is a vertical element that goes very high very quickly. Now, all these were not actually specified. So no one told us, how do you want the concrete to pass the congested steel, or inform us about what type of flowing ability, the filling ability, the stability of the mix, and what is the pumpability requirements. How do you translate pumpability requirement into numbers, into fresh concrete properties? There is no book that tells that. Even at ACI, you don't find this, because there is no project of 1,000 meter or 800 meter concrete pumping. So we had really to go into a big development program. First, we had to use the right admixture. So it's a polycarboxylate-based admixture, of course, but we had to add a retarder to make sure we had the retention. This is hot weather concrete, and it's not something you would just play with, especially when you have the core walls, and sometimes they take time. The aggregate was the key for the models of elasticity, and I'll talk about it in a while. You want to make sure that you had the water cement ratio low, so to achieve the high strength requirement, but if it was too low, you'd have other problems with the pumpability. So that was another balancing act required. And the optimization process, as I said, the contractor was looking for cost, and want to make sure that we have all the ranges of water cement ratios required to make sure that we address this project properly. We use fly ash as a partial replacement to reduce the heat development, and we use silica fume. We optimize it at 7% to make sure that we get the water cement ratio low enough and we get the durability and the permeability requirement. And we had to really play with the fines and the coarse content and the viscosity modifying agent to maintain the mixture stability. So what we did, we actually put some limits on ourselves. We said, all right, this is 100 MPa concrete. This is the one that's going into the core walls. And the 100 MPa concrete should have a slump flow of 700 millimeter, which is quite high. J-ring less than 25 millimeter. J-ring is the difference between the slump flows, one which is without the actual cage, and one after the cage, and the difference should be less than 25 millimeter. The V funnel, less than 13 seconds, 0% column segregation test, strength 100 MPa at 90 days. We agreed with the engineer to be 90 days for the strength. Model of elasticity required was 43 gigapascal, and the permeability required on the 1202 was 1,000 coulombs, 20 millimeter penetration on the DIN 1045, and the water absorption, the European test, 2% maximum, and the maximum temperature of concrete was 75 degrees. So these were the actual requirement, and the actual came all right, except for the modulus of elasticity. It was impossible for us to achieve 4 to 3 gigapascal. And you know, when you have a tall structure, the reason why you specify a modulus of elasticity, because you don't want the people on the top floors to sway with the building. So you want to minimize the sway of the building. You want to keep some sway, but not something that makes it uncomfortable for the people living there. And especially that the owner of the building will actually live on the penthouse on the top floor, and you want to minimize the sway. So MOE was a very critical requirement. So we also had to do high altitude pumping trials. We cannot tell the contractor we'll pump it up 500 meters and then another 400 or 380 without showing him that we can do it. And how can you show it? I mean, you don't have any place where you can prove that this is doable. So we had actually to simulate the vertical height with horizontal length. So we did a 1 kilometer horizontal pumping line, and we had elbows and flanges to increase the pressure. So we simulate the vertical height with the actual pressure on a horizontal level. So each elbow was 1 bar, each flange was half a bar, and we added that. So we designed that system to simulate even more than 500. This is the 1 kilometer that we did actually. And we did the high altitude pumping trials with the mixed design that we finally decided on. And we started checking the J-ring and the stability and the slump flow and the V-funnel. All these were important. And we found out that on a height like this, the V-funnel becomes one of the key elements for pumpability. The V-funnel test becomes the real secret, whether this concrete is going to be pumped so high or not. So anything below 13 seconds was acceptable for us, but we found out that we needed actually 8 seconds to get the mix to reach there at the right flow. We had even to look at the pump pressure. We found out that anything above 200 bar on the pump will not take the concrete up there. So we had to actually reduce the pump pressure below 200 bar, and we had to work that out by first taking the pump away from the first elbow. So you had a horizontal distance, which is 25% of the vertical distance that you should maintain. And then we get some also slope for the initial horizontal outlet of the pump to make sure the back pressure on the pump is not very high. So when you pump the concrete and the concrete is going back, it doesn't really add on the pump pressure. So we even used the Bingham model. We actually had to test the yield stress and the shear, as you saw yesterday in one of the presentations, that when do you use this? You use it when you want to make sure that with all this pressure, this concrete will not lose its stability. It will not shear up, and it can resist a certain stress. So this is a very necessary element, testing property that you need to have when you are on site with projects like this. So we tried to get the flow above 600 all the time, and made the pumpability limits to be below 200 bars. And as I said, 13 seconds was the limit, but we found out that we actually needed much lower than 10. I mean, we could still pump with 13-second, below the 13-second V funnel. But to really have a proper flow that keeps the concrete going, you needed 8 to 10 seconds. And the viscosity...
You have 2 minutes.
Yes, we're finishing. 80 Pascal second, we want to maintain that. So that's why we said, we don't need self-compacting concrete for many reasons. One, it's very difficult to control at the batching plant. Second, we don't want to have a high viscosity. It will be very difficult to pump this concrete. It will be very difficult to manage it. And the QC measures at the batching plant were already very difficult. So with SCC, it would complicate even our task further. And the main problem was to find the MOE, the 43 GPa, and we couldn't. And we told the engineer, we changed the aggregates, and we found out that the aggregate shape, the quality of the aggregate, the nature of the aggregate, the geology of the aggregate was so important to get the MOE. And we convinced the engineer that, we're not able, the strength kept increasing, the MOE was not increasing. So this relationship between MOE and strength, which was proportional, did not work. So when we changed the aggregate, things became better. So we agreed with because the engineer had, a very high stringent requirement of 43. He accepted 38 because this is the thing we could actually achieve. What I'm trying to say here, and then in conventional concrete construction, you normally have pumpability or placing, workability, strength, and durability. But when you come to super tall structures, you have so many other things that you have to balance. And when you balance that, you have to engage the designer with you because they don't know about the fresh concrete properties. How do you achieve this pumpability requirement or the rheology that was demanded? And that's why you need a balanced approach. And this balanced approach is something that was not codified, so we don't know about it. So I think one of the conclusions is once we have this information out of the Kingdom Tower, we'll be able to codify some of the fresh properties, requirements, and the balancing approach into codes and guides. And I think the other conclusion is that when you have a super tall structure, don't run into the hardened properties before you do the balancing approach properly between durability, pumpability, and MOE. And one final conclusion is that based on the information that we have today, we can easily pump concrete above 1,000 meters. The technology is there, admixture technology is there, mixed design knowledge is there, and what we have seen is that with the pumps out there, you can actually pump concrete above 1,000 meters. Thank you very much.
Thank you, Mr. Abbott. I think excellent presentation. Please give him a big hand.
Thank you. Thank you.
Yes, one question.
Yes.
This particularly concrete mix design, you are telling it's a flowable concrete.
Yes.
But you are telling it's more than 500 mm, that's all. What was the highest flow you got? Because more than SCC, viscosity is lower than SCC. That's
yes.
what you mentioned.
Absolutely.
This is one question. Second question is modulus of velocity doesn't match with the established relations.
Yes.
You told the reason is being you wanted to limit the sway. Third question is creep tests were conducted in this particular study.
Of course. We have a full structural health monitoring system. So there's sensors on every core wall and different sections of the building. I have a different presentation on structural health monitoring, what we're doing there. So we're monitoring there and we're checking the creep and the shrinkage, but we're testing the creep because what we found is that the first 6 months, the creep is something that you have to test before you can start using the correlation in the formula. Whatever you do, you have to use the testing results for creep in the first 6 months. After 6 months, you can start using the models that are out there for creep. But yes, we tested creep and shrinkage, and we check them every 30 days based on the structural health sensors that we had in the building. So that's the last question. The second, yes, we had 600 millimeter flow and 700 millimeter flow, slump flow. We could not use SCC because we did not want to have the viscosity high. Once you increase the viscosity, you will have other problems with pumpability. The pressure will build up. It's very difficult to pump SCC. One of the other issues with SCC is that the reason why SCC is not becoming, every concrete, very difficult to control at the batching plant. Even if people tell you, yes, we can do SCC, I was in the ready mix business, we can do SCC, yes, but to keep it consistent throughout the time is going to be very difficult at the batching plant. One of the reasons is that the batching plant tolerance for the scales, plus or minus 2% on aggregate, plus or minus 1% on water. These percentage, when they sway, plus or minus, so you have 4%, the effect on SCC is huge. So that's why SCC is a very tight thing to do on a batching plant, especially for a project like this. On the models of elasticity, we had to talk to the consultant because the engineer wanted a high models of elasticity to reduce the sway. So you don't want 3 meters sway at the top because it will be uncomfortable. And that's why they required 43 gigapascal. And we could not achieve it with the existing aggregate. Even when we changed the aggregate, we went up from 35 to 38. We reached 40 in sometimes, but we said the limit minimum should be accepted as 38. And then the engineer did his calculation and accepted that. So it was a discussion with the engineer. When we showed him what we did on the fresh properties, he realized that there was no other choice because everything was documented with his inspectors and the engineers on site, and they saw that there was no other way to do it. And if we did not do it, we could not pump concrete up.
Okay, thank you very much.
One more question, sir. Last.
Yes,
Here.
but I think we are
Last, sir.
fighting with time. You
1
can
minute.
interact with him.
1 minute, sir. Last.
Okay. Okay.
Sir,
Okay.
actually, you have specified strength criteria in 90 days.
Yes.
But in India, the major consultant, they specify strength criteria in 28 days, like 70 MPa, 80 MPa grade of concrete. They want in 28 days. So what is your opinion on this?
You know why it's 28 days? Why did we all use 28 days? Why do you use it? You know why? We think that concrete will get 90+% of its strength within 30 days, right? But we don't want to come on a Sunday if we pour on a Friday. So we said, let's make it multiple of 7, close to 30 days. The second reason is that we don't want the contractor to wait 2 months for his billing. So we want to make it within 30 days. So that's why we chose 28. So 28 was an arbitrary number. So start with that, with the discussion with the consultant. There was no scientific reason why it's 28. It's just a convenient number close to 30 where we believe concrete achieves the majority of its strength. Now, when you have a project like this, you have only dead load, right? In the airport, even there is no dead load when you're doing pavements and other things. So the engineer should be open-minded to understand that 28 days was initially an arbitrary number. You're not talking about live load. You're not talking about wind load yet. So you're still in the safe side when you say 90. Other than that, it will be uneconomical to do it. We can still do 28 days, but it will not be economical. It will be much more difficult for a project like this to manage less than 90 days concrete, grade 100. So depending on the nature of your project, if it's flat and there is no dead load, you can convince the consultant. If it's a vertical building, then you can say, you know what, when do you need your live load? When do you really need the structural load to be 100 or 70 in your case? So it's a discussion you should have openly with the engineer. And this is an example of sometimes the specifications are not right in everything they say, or they're not clear about everything they say. And an open discussion with a balancing approach should be there.
Okay, thank you. Give him a big hand. Excellent lecture. 1 minute, sir. 1 minute. 1 minute. 1 minute. 1 minute. I request Mr. Srinivas Reddy from Design Tree Consultant to please come on the dais and please hand him a memento. Okay, thank you, Mr. Reddy.
Thank you.
And thank you, Mr. Abbott. I think we are now ready. Already Nagesh is there outside, and whatever we have left yesterday, the seminar on by JSW and Fosrock. So is JSW Fosrock? Yes, Banju, will you be there? Okay. Nagesh.
Good morning, Vijay sir.
Good morning. Are you ready?
Yes, sir. I think I will be beamed now.
Okay. Now I request Manju to start.
Good morning, respected delegates. Today, the demonstration of high volume GGBS, that is 70% replacement using fast rock admixture, Mix 450. Yesterday, the first lecture, Chatterjee told us that, okay, how you can bring down the CO2 emissions, making durable constructions. If you use OPC, let us have an M30 grade concrete, I was talking about for cubic meter, 292 kgs of CO2. If you use fly ash, about 30%, it's coming to around 228 kgs. If you use 50% GGBS, which is slag, which is something like cement only, it's coming to about 161 kgs. Let us say you use 70% GGBS without affecting any properties of concrete, without making any changes, it is coming to 117 kgs. Imagine when we construct the entire structures in India with such a replacement, how much of CO2 emissions we are going to save for the country which is driving for climate change. We have signed the agreement in Paris, our Prime Minister, to bring down the CO2 emissions in India. So, to that effect, how we can do that? So, we need very good admixtures. They are the backbone for any mixed design. So, we have from Fast Rock, Mix 450, which is a new generation PC-based admixture, which my friend Vamdev will talk about it. So, this is one, like generally all the consultants or government department, they fear using any cementitious material. So far we always have 50% of the concrete which is being made in India, OPC mixes. So of late, they started using fly ash. Now a new generation mineral admixture, like RMC plants are using about 50%. So we thought how to change the dynamics of this concrete, how to make it more green, more eco-catching today. So we know this is the total content introduction, brief about GGBS, admixtures, chemical admixture, and market expectations on high volume GGBS. And high volume 70% GGBS trial mixes we have done and demonstration trial. This is the outline of the presentation. Looking at GGBS, this is a byproduct of steel manufacturing where you use high quality limestone that not even used in cement industry. They have used about 98% purity of limestone, imported limestone, which is having very rich calcium. As I already told you, using high volume second is cementitious the CO2 emissions, make the concrete green and sustainable. Yeah.
Hello, Manjunath.
Yes.
What we will do is, because there is a mixing process involved,
Okay.
I will explain what is this. We will start loading the drum. You continue with the presentation. By the time you finish your presentation, the concrete will be ready, instead of stretching it long.
Okay.
Okay. Right. Good morning, ladies and gentlemen. This is the second seminar of IC of cement by granulated blast furnace slag, ground granulated blast furnace slag. Apart from that, they would like to emphasize on the point here that if there are some variations at site, the same mix design, the same kind of chemicals would be in aggregates, the mix will still be the same. That's something that we always have the problem at site. The fine aggregates get into the trouble of not getting things right. Right now you can see here, this is the high volume of GGBS and very little amount of cement. So this is 30% cementitious material you are going to have. You are going to have only 30% pure cement and the balance is GGBS. And what we have here is typically the zone 2 sand and zone 1 sand. You can see that coarse materials are there. Now what we do is we start loading the drum with we'll start mixing the concrete here, probably without the audio on the one corner of the screen, you will be watching what is happening.
What type of mixer? Because you are mixing too many powders here.
Yeah, we are using a pan mixer, sir. Can we?
Okay, okay.
So the advantage of using GGBS not only is the bring down the cost of concrete making substantially, it gives other benefits like enhanced durability, reduced temperature in mass concrete applications, reduced advantages of using GGBS in high volume concrete. I request my partner Vamdev to take over.
Yeah, thanks, Manjunath. Yeah, very good morning. My name is Vamdev. I am the Marketing and Technical Manager from Phosrock Chemicals India Private Limited. As Nagesh said, today key points are, we are going to demonstrate two things. One is high volume GGBFS, that is 70%. Other key things, we will be demonstrating 3 trials where the variation of sand is there, zone 1, zone 2, zone 3. So with this, key things, early strength development will be slightly higher than the GGBFS mix. But at 28 days, it is very close to the, what we get is in the strength will be there. If you take this GGBFS, all the latent hydraulics, what it is there, suppose if you take OPC, GGBFS, it is like specific surface area, it is very close to, we have a pointer here. See, very close to specific area, if you take, if you take specific area, this is very close to the, between OPC and GGBFS, these are very close when compared to the fly ash and silica fume. Probably this could be the one of the region where it can accommodate so much of replacement. See, we have many advantages with the GGBFS. The one maybe the limitation I can say to overcome this limitations. See, probably these are some of the things where we can see how we can overcome this. Probably increasing the surface area of the GGBFS so that the reaction hydration will be slightly faster. What we understood from JSW is that earlier they used to have around 320 surface area. Now they are grinding it to the 380 actually. That could be one of the reason it can help in getting the early strength. The other one is by reducing the water cement ratio, and the point of young engineers who present here. See, we know the properties of the concrete, the workability, strength and durability. Okay, these are the 3 properties. Apart from, see, workability, the ease with which concrete can be produced, transported and placed at the place where it is required without any compaction. So to produce a good concrete, we require adequate workability. So just assume that there is no chemical admixtures. How we are going to increase the workability? Either keep the cement constant and increase the water cement ratio. Alternatively, keep the water cement ratio constant, increase the cement content. In either way, if you increase the water content more, it is going to affect the durability and strength. And even if you increase the cement unnecessarily, okay, it is also not good for the concrete and also from the point of economy. So this is where we are looking for a chemical admixture where it can improve the workability without affecting these 2 properties. So what is this chemical admixtures? This is a additive added to the concrete to improve or modify the some of the properties of the concrete. As you already know, I will not take much time on explaining all these things. See, chemical admixtures like water reducing admixtures are used to increase the workability. See, earlier we were talking about only the slump. Now the people are looking for flow concrete of 600 and 700 flow. Chemical admixture is very much necessary a long time. So the most of the now requirement is the retention of slump, 3 hours and beyond. Even people are talking about 4. And to achieve the early strength, see, of late, lot of precast constructions are coming out. People are looking at 8 hours 10 MPa, 8 hours 15 MPa, especially in the precast industry, to make the farmer very turnaround. The early strength, earlier, we used to get this use steam curing. With the invention of this PC-based admixture, so without any steam curing, we are able to achieve successfully at 8 to 10 hours, very easily we can achieve the 10 to 12 MPa slump, so that it will be, enough to, handle the concrete. Secondly, the high, so the stickiness has to be reduced actually. So, nowadays the PC admixture which are available, so that will help in getting the stickiness reduced and reduce the bleeding and the permeability. See, now the market, what exactly the market, look for, especially for this part of world where the, slag is easily, now they want to go slightly higher, maybe probably 60 or 70% from the point of durability and economy. And when they are using such a high development, should be very similar to the current one, like 40 to 50% replacement. And also another requirement is, as I mentioned, from the point of this tunnel forming or Maiwan shuttering, high-rise buildings, people look for more flowable concrete than the conventional slump concrete. And also, see these, variations, when we are using this high volume slag or the chemical admixtures, see, this should be robust enough to take the, and also it should be less sensitive for the any variation in the, sand grade, or when we are using such a high fly ash, so the other aggregate also to support. Just to say one example, the other day we were in Bangalore International Airport where they are doing the PQC. Even though they are getting, required strengths and all around 50 to 60% replacement, because of the aggregate, the QC manager has said they are restricting to slightly around 40 to 50%. So the quality of aggregate also very important to increase the, with the 70% of GSW, GGBFS, and with our admixture or a mix 450, I'm sure definitely this is going to add at least some data and value to the this high volume fry house requirements. So these are the material currently what we are using there. We are using cement, OPC, Ultratech cement, slag from the JSW, and chemical admixture, that is PC based admixture from Phosrock, that is Aramix 450, the brand name, and we are using local aggregates. As I mentioned, the fineness of late has been increased from 350 to 380 meters square per kg. This has been confirmed by JSW, and also there is a
6% glass content. It's equivalent to any global GGBS available. So we are producing world-class GGBS. That is advantage, so that tire replacement can be done.
Just to brief about our admixture, what we are using, it is a PC based admixture, new generation admixture. It gives very low viscosity and very low stickiness. With this we can get very low stickiness, especially this kind of admixture is ideal for the supplementary cementitious replacement like high volume slag or something like that, even from the point of pumping, and very long workability. We can see the, we have already done, we can easily get 4 hours, beyond 4 hours workability retention without any slump loss.
To interrupt you, the first mix is ready, the second one is on, and in order to release the drum and save on time, I'll be interrupting you. The concrete mix with zone 2 is ready. You can see here. I'll take the flow, the cohesion. What you see on the rear side. One sand, the mix is going on. Quickly, I will show you what is the flow. Okay, 1, 2, 3. Very good, very important thing to notice, the concrete is flowing, no bleed water observed. This is zone 2, sir. We have Dr. Nagendra with us verifying which is the zone of the sand. Flow is 620 mm flow. Quickly we will take up the next one which is ready.
You take in the other direction also?
Can we measure the other direction? You have Vijay Kul.
Okay, okay.
Yeah, you can see the mix with the zone sand, and yeah, we will, demonstrate the zone 1, zone 3 also meanwhile. So just I was briefing on our chemical admixture, what we saw any VMA we are supposed to inbuilt into the PC-based admixture, it was not very cohesive actually. So of late, the development is we can inbuilt, either we can give separately. So we can inbuilt all the retarders required, and we can inbuilt all the viscosity modifying agent also is required, and it is compatible with the 100 here. Just to brief on this PC-based admixture, as I mentioned earlier, okay, because of these functional blocks, now we can blend all the retarders and the VMA in single admixtures we can give, and if any wants some separate retarder from the point of control, quality control or separate VMA, that is also available. But one point I stress here is, nowadays the PC-based admixtures available in the market are retarder and VMA. That was not the case earlier when the PC market, admixture was introduced into the market. The cement content is 114 kg per meter cube, and GGBFS is 266, that is 30%, 70% replacement, 70% GGBS, and 30% OPC. And 20 mm aggregate, if you take sand, is around 53%, and water cement ratio is 0.4. Admixture dosage, it varies from 0.6 to 0.75. Anyway, we'll just confirm with Nagesh what is the dosage added there. So these are the CO analysis of the material what being used there actually exactly. This is the zone 1 sand and 53% sand. Similarly, this is the zone 2 and zone 3. So we did some trials before coming to here. So I would like to show the both rheological and 620. Even after 1 hour, 620 mm flow, and even 120 mm also, there is no change in the reduction in the flow. And these were the theoretical densities and fresh weight density. And 3 days we got around 16.1, and we, in fact, we did measure the 1 day strength and 28 days around 40. And similarly for other zones, what we got in this range.
Vamdev?
Yeah.
We are ready with, this is zone 3 sand. Hello, hello. Check. Am I audible there?
Yeah.
Okay.
Nagesh, please confirm what is the dosage was used there.
0.8 dosage.
Yeah.
Mr. Vamdev, I have a question.
In both the cases? 0.6 and 0.8, whereas all other ingredients are same. Vamdev, and Vijay Saab, I'm getting a clarification here.
Yeah.
0.6 ingredients, including water, has been kept constant.
Okay.
Just they have tuned up the admixture dosage, and looking physically, it's still moving, but physically looking at it, we have got the same flow that what we got last time.
I think the shape is little different.
Yeah. 640. Can you go on the other side also? 590 on the other direction. Vijay Saab,
Okay.
what we have to look at here is the smoothness that we are going to get.
Okay.
I'm just bringing things nearer to the camera.
Yeah, it is visible.
Yeah. Probably when we are looking at what is called as form finish concrete these days, these kind of robustness in the mix would definitely help.
Okay.
Thank you. And the third mix will be ready by the time Vamdev completes his presentation.
Okay, thank you.
Yeah, thank you, Nagesh.
Meanwhile, 1 minute. Dr. Nagendra is here. He has a question to Vamdev.
Okay, welcome.
Mr. Vamdev,
Yeah, please, sir.
irrespective of the zones, that is zone 2, zone 3, and zone 1, have you kept fine aggregate or total aggregate proportion same?
I think they are the same.
Yeah,
Can you hear me?
yeah, I'm hearing you. Just I'm looking at the mix. See what we did in laboratory 991 we are used for the zone 1 and 928 for the, this weight, same thing.
So as the zone increased from 1, 2, 3, you
Yeah.
reduce this sand content.
Yeah, zone 3 we have reduced. We are 879 against the 991.
I just want to make some correction. It's not the same mix. Mix are different as per the zone. When
Okay.
the zone changes, definitely the mix has to change. So those corrections have been taken.
Only the cement and the GGBS contents are same.
Yeah, you're right.
Total water content has remained the same.
Yeah, yeah, total water content is same. Yeah.
So it is the fine powder GGPS and the admixture is making the concrete to flow. Yeah, now my next question is, which one is most predominant here? Is it because of GGPS or because of the admixture? We are getting the flow. To question to both Manjunath as well as to Ramdev.
Come back, come back.
This is called trapping and falling into own trap.
So let me
Yeah. Yeah, these are the, as I mentioned, okay, these are the some of the properties in these slides. Otherwise, I am through with the presentation. The live demo is going on. Yeah.
Okay. Any questions you can take Vamdev by the, because I need another 3 minutes to complete this job. Here, the mixing is on. So by the time the drum is taken out, you can take questions there. And the tricky question that Dr. Nagendra has pitched in, we have Shiv Prakash here who says he would chip in with the answer.
Yeah, yeah. Okay, go ahead, Shiv Prakash.
Very good question. Basically, we just want to understand which is contributing for the flow. Obviously, we have done a trial even without admixture also. When we have done trial with admixtures, basically this slump was only initially 20 we got it. So it's a very dry slump because we wanted to compare whether the admixture is playing any important role with respect to strength. So that's what we wanted to check it up. So initial slump we got it about 20. Admixture is definitely playing a major role getting this flow of concrete. One more important point what I'd like to mention is here. The strength parameter gain, what we talk. See, normally when we go for high volume replacement of GGBFS, so we have a apprehension saying that your strength gain parameter on 7 days and 28 days is going to be lesser. But here the scenario is slightly different. It is going at par with any 50-50 replacement with the OPC and GGBFS. Reason is only one thing. I had a discussion with Manjunath also on this particular subject. The fineness of the GGBFS has been increased from 350 to 380. So this particular fineness is playing a very important role on this particular matter.
Okay, Shiv Prakash and Vamdev.
Yeah, please.
Yeah, you complete, sir.
I will ask question from my side. Vamdev during the presentation has mentioned that this admixture, the robustness, irrespective of the grade 1, 2, 3, it happens. My question is it the robustness is mainly because of the admixture, or is it also because you are changing the grading, the quantities of each fine and coarse aggregate you are changing? This also helps in the robustness that what you are trying.
Yeah, see, I mean, change of, especially the sand, we try to, I mean, fix in the all-in aggregate. If you take the changes, I mean, not very significant, but I'm telling you, without changes also, we have done the trials. See, the key is here, the admixtures, we are inbuilting VMA into this. See, I mean, these, I mean, even though slightly we have reduced the, as the zone 3 goes on, we have reduced the sand also. When zone 1, we have increased the sand, but we are keeping the all-in aggregate together. But total fines, if you do, if you go as for the changes, it is almost same. What I stress is the robustness, what we are getting mainly from the point of admixture, where we have got inbuilt VMA in this. That is the key. It shows the robustness in this mix.
I will elaborate on something which they are speaking.
I just add on to one more thing. See,
don't
when
create
once we go
confusion.
for a gap grading, this thing, the mix reason has to change. It cannot be same at this point of time. So that's what the thing what we have done. Because when we go for analysis of same analysis of zone 3, so in this particular case, it's not meeting the combined aggregate. So when once we do that, the mix proportions will change.
Vijay sir, we are being heard there.
I think we are, you have been heard. Now you can show the third demo.
One question, as the things are going on for both Prakash and Vamdev there. Now, powder content and other things going on, the demand is more on a low strength concrete around M25, M30 or even M35, but they need the flow. Will the robustness continue to that segment as well? But or are you going to ask me just like SEC, whatever you do in SEC is M40 and above?
Okay, let me answer this particular question. The mixed design, what we have taken is for M30. This is a M30 mixed design where the cementatious content totally is only 380 kg. So it's not that M40 or M50 what has been designed. All these things is for M30 mixed design.
Okay, that means the construction chemical industry and the other industries concerned are answering the questions of a common construction practice. Thank you. And Vijay sir,
Hello.
here is the flow.
Yeah, correct.
620 dosage is 0.5. 0.55.
You can see, based upon the zone of sand, the dosage also varies. Zone 1.55.
565 is the other direction.
Okay, okay.
Point.
I have a question. With 70% replacement of GGBS, what would be the 3-day strength and 7-day strength of this particular concrete?
Vamdev,
Yeah,
I
I
think you should take it.
Yeah, we have
this.
actually just shown in the presentation.
Okay. Anyway, that I'll pick it up from Vamdev a little bit later. Me and Ragendra both have access for it.
So 3 days normally what we are getting is between 16 to 19 Newton per millimeter square. So when you go with the 50-50, you get about 18 to 20. There's a small difference between this. But when you go with the 7 days, we are getting M30. Because
Hello.
Yeah.
The strength data, earlier strength data is with us here.
Yeah, we have the strength data.
Okay.
Yeah.
Okay.
Thank you.
And this is Nagesh signing off for the moment. I'll be coming
Hello.
back in the afternoon.
Nagesh, one more thing. Do you have a V funnel there?
Do we?
No, we have not bought the
We have not bought the V
Okay,
funnel.
ठीक, no
Thank you.
We
problem.
have done the V funnel test also. V funnel
Okay, sir. Thank you. Right now, we will go out of air. Vijay sir, can you ask the next presenter? The list is available on the MC table.
Okay, ठीक है, thank you. I think you can continue.
Yeah.
In the meantime, any questions?
Thank you and congratulations.
Yeah, just to inform that V funnel, actually, in fact, we did the V funnel for this. It was because since we are using 35% 20 mm aggregate, it was around 22 to 25 seconds. Actually, we measured that V funnel before coming here. But when we use the 10 mm downsize aggregate, it is very close to 13 or 14 in that it is coming.
Hello, I have a question. You know, your water cement ratio is 0.4.
Yeah.
And grade of concrete is M30.
Yeah.
So don't you think this is a too low water cement ratio?
No, this is the common mixed design for M30 being used here because replacement level also we have to see. The 70% replacements are there. This is not specially designed mix actually. We have taken from one of the ready mix concrete from Bangalore. The same we wanted to replicate it, demonstrated here. This is the where when we are using 50% and above, either of, fly ash or GGBFS, the normal water cement ratio is around 0.4% people are keeping for M30 grade concrete.
No, because generally 0.4 you are likely to get around M45 or that grade of concrete.
No, but that is you are maybe talking about the OPC. But when you use the OPC, that is fine actually. Even we can go up to very close 0.48 and 0.5. When you are using such a 70% replacement or 50% replacement of GGBFS, normally people keep very close to that is the practical what being used in most of the RMCs here in Bangalore, especially for this Maiwan or tunnel forming constructions.
Yes, one more question.
One more question, please. If I'm going for 0.3 water cement ratio, will I get the same flow?
We have to increase the dosage. We will get the same flow. The dosage instead of what we are using 0.5, 0.6 and 0.8 for the different zone, probably we have to increase the dosage.
When I go for highest and like M60 or M65 with 0.3 water cement ratio,
Yeah.
will I get the same flow again? Or the highest end?
Yes,
Again,
sir.
I have to increase
It has been used our admixture. We consistently M90 for higher grade of concrete. We have got very similar slump 620 days. Only the dosage has to be increased with the same admixture. You need not to change in the formulation in the admixture. Dosage, whatever that water cement ratio you reduce, we have to keep on increasing the dosage till we get your realizes.
Sir, basically from the discussion what we understand is the admixture type is constant, except the dosage variation is happening, it depends on the grade of fine aggregates.
Exactly, sir.
Or aggregates.
Yeah.
But sir, we are debating from some time now, what is contributing for the flow. You were told one important property that VMA, inbuilt VMA. If admixture type is same, inbuilt VMA also will be constant, no, sir?
Yeah, inbuilt VMA is mainly to take care of the robustness of the mix, where the zone variation or any slight variation in the moisture when we are practically doing in the batching plant. But the main, the flow what we are getting, mainly the water reducing agent present in the PC based admixture.
So inbuilt VMA changes doesn't happen. The moment you inbuilt it is constant, it becomes constant.
Yeah.
When we add separately, only that variation can be done, no?
Yes, I told you, these are available both. We can give separate water reducer, separate retarder, and separate VMA. And some people say that, okay, we do, 3 dispenser we have to maintain. We do not want, we want to, make very simple. We want all the 3 ingredients to be inbuilt in one. So that also is possible. But earlier, what I stressing was, earlier PC when introduced to the market, it was not possible to inbuilt all the retarders and VMA. So now there are polymers which take care of the rheology that is compatible with the present day, the PC based admixture. That is the point I am stressing there.
Thank you, sir.
Thank you. If we can add, okay? Just to benefit of all, and if I contradict anything, I'm free to do it.
Yeah.
Let us not confuse with the fundamental concepts of concrete technology. Everything looks to be in order. In order anything to flow, we need powder. Now earlier we used to use only cement as a powder. Now it's a manufactured material, high energy material. Now whether something can be brought down, it's actually a very good material. Now whether that can be replaced with cement makes sense for most engineers, including whatever has been presented. But 400 kgs of powder has been maintained, please make a note. Now JSW is incidental here, you can use any other powder, but if you use a inert material, let us say fine sand, you may not get the type of strength which they are projecting, but you may get a flow. The next question for you is the again new advent in the last 4 for a kind of a flow, and then add glues or viscosity modifying agents. If you don't want that organic material, we use the variation at this site. It's very difficult to control. That is the point which they are trying to make. Zone 2, Zone 3. Quality control engineers will not have a control in thousands of cubic meters of concrete when they do. Now whether that can be controlled at this site is what they are trying to demonstrate.
Hello, there is one lady who is there. Yes, you can ask this question.
Sir, I'd like to ask whether the performance of Auramix 450 is same for all brands of cement, or these trials are done for a specific cement brand, because normally what we have seen is the performance of admixture varies when there is change in the cement brand.
Yeah, if at all varies, only the dosage can vary actually. Okay, even instead of Ultratech cement, probably use any other cement. But okay, in fact we did with the 3 cement. One with Dalmia cement, another one with ACC and Ultratech. But we did not find much difference. Maybe okay, this is a particular batch actually. But the admixture is robust enough to take care even if you change the, cement also. Because here most part of the cement is 70% is GGBFS.
Okay. And retention will also remain the same.
Yeah, yeah.
Thank you.
Unless, okay, you are, chemical composition totally different of C3A content, if it is more than 7, 8, definitely it is greatly affecting the, reduction in the slump retention. So normally, if you are keeping anything around 4, 5 C3A content, this will be, you will get very good consistent retention. But if C3A content goes on 7, 8 or 12, something like that, it will have a major impact on the retention of the concrete.
Thank you, sir.
Thank you.
Hello, I think, is there any other question? Otherwise, I will ask one question, allow me.
Yeah.
The major question is that I think I would request JSW and POSROC to conduct accelerated carbonation test on the mix that they have done and show that the carbonation depths are within limit. Other alternative, as has been known to all of us, is to increase the grade. Instead of M30, why not increase the grade, reduce the water cement ratio, and go for higher grade of concrete so that the carbonation is not a big issue. So the strength should come through durability. So this is a request.
Yes, yes, sir. Thank you.
Thank you, Vamdev. May I request Dr. R.V. Rangnath to kindly hand over a bouquet?
Thank you, sir. Thank you.
That was, thank you, Dr. R.V. Rangnath, to bringing in that fine, basic things that people have to think about when mixed designs are made, especially with fine powder. Thank you very much for that. And we will now have a presentation from Messrs. Ramco Cement. And I also request people from Fisher to be ready.
A very warm good morning to all of you. In fact, we from Ramco Cement, my name is Anil Kumar Pillai, and I am heading the technical services. Most of the professionals we had met celebration. So again, having a nice to meet you again. When we look at the topic, scale it to a larger, larger size, there are many challenges. So we have also been interacting with many project personnel, and we have also seen those challenges that comes up from scaling from small sample to a bigger one, because there are limitations. The thing is that just to share some of the developments that we have at our Ramco Cements. All of you would be aware of the organization. Just, confining myself to the cement, we have our cement plant mainly in the state of Tamil Nadu, Andhra Pradesh, Karnataka, and we are all. So as you could see that we have convenient location in terms of grinding units, integrated plants and packing plants, so that logistic. In fact, our group started into cement manufacturing from the year 1961. So we are, an early player into the cement industry at a time many. Of course, our expansion projects which are on the anvil and which are in progress. In fact, our Jendipuram plant, we are expanding the line 3, and also because of the various thing that we have. Some of the key projects which has been categorized into various categories like nuclear projects, infrastructure projects. We are not going into deal with all the projects, but just to give you an overview of the kind of this thing that we have gone into. Indian Rare Earth Limited in the state of Odisha. Of course, it comes with the usage of blending material, like fly ash, because the thing is that without the blending material, we may not be as per the codal, because the thing is that it goes much beyond the codal provisions, whether it is heat of hydration or whether it is chemical composition in terms of tricalcium aluminate or combination of which needs to be given attention to, because what they look at is the temperature of concrete as well, and the densified concrete mass which is required for such kind of projects. Of course, the industrial buildings that are there in the state, in Mysore itself, we have been associated with the Asian Paints project, where we have been a major supplier there for basically M25, M30 grade of concrete, which they have been using there. In the state of West Bengal at Panagarh. When you look at the industrial buildings, basically what they are looking at is, apart from the grade of concrete, they are also looking at the durability aspects, which in many cases, as you could see, one of the speakers who temperature of concrete, I think many of these things play a vital role as far as the industrial buildings is concerned. MRPL project, where we have been involved with the pile foundation and other structural works, where apart from strength, workability is also a critical parameter. And the slip form technology has its own requirement as far as the rate of gain of strength of concrete is concerned. Cooling towers within the thermal power stations, which again has its own challenges. So we have been associated, is also too stringent. You need a concrete with strength, high workability, longer slump retention. Sometimes we have also seen that the concrete is being 3 hours or 4 hours, things like that. And to maintain that consistency in quality of concrete becomes a challenge. Of course, at various water cement ratios ranging from 0.65 to 0.25 and 0.2, how to maintain that. We have seen that many of the international projects or the international consultants which are executing projects within India, they specifically look at the durability also. So these are some of the infrastructure projects which we have been associated with. The first of the few projects, the thing is that you could see the precast elements on construction, and that is how we introduced the rapid hardening Portland cement as per IS 8041 with usage. Of course, under infrastructure projects, some of the special projects where they have been specific requirements, as I was mentioning. This kind of continuous pour. They wanted cold joint. They didn't want a cold joint, so they went in for a continuous pour of concrete, lasting for about 3 days. This one for shotcreting and other applications there. Bangalore Water Sewerage and Supply Board, again, they look at specifically from the sulfate chloride attack of concrete, which needs to be fulfilled. Of course, hydroelectric project, where they are looking at heat of hydration control for this mass concreting. Some of the mega buildings, of course, within Bangalore itself, we have been a major associate with L&T in this particular project, where the challenge, of course, is, as many of you were mentioning, pumping concrete to greater heights. Again, here, the usage of My1 shuttering, self-compacting concrete, giving a concrete with good finish, doesn't drop. And, where the admixture dosage and sometimes mixed design needs a change as we go up the height because of the change in various parameters of weather. This is, again, a project which is being executed by Brigade in Bangalore itself for precast panels, where we have been supplying have been doing this. One of the challenge that we have seen is that many of them are just leaving the concrete like that. So they do not even want blowholes on the concrete, appearance of blowholes on concrete surface, which may be because of, sometimes the release oil, which critical projects wants concrete without blowholes as well. Of course, all this is not possible without judicious use of both mineral as sensitive to this kind of issues. Of course, all of us are aware of this, on how we take care of this free lime. The usage of fly ash is nothing new, because it was there right from the Roman era, and heat of hydration can be lowered. Of course, feedback from various projects has resulted in kind of learning for us. In fact, we have been able to give a cement that is customized to the project, and working in close coordination with the project team has resulted in a data bank of mixed design at our Ramco Research Development Center, which is being helpful for many of the projects which is yet to come, that we have been receiving 4 Leaves Award, Green Pro Certification Award, because what is important is how to ensure that the environment is also saved. So in that aspect, even the technology that is being installed in the cement plant, both in the existing one as well as in the expansion projects, needs to be given more attention. Of course, the world-class technology that we have, whether it is in the mining, because limestone mines, where we have installed optical sorters, optical sensors, and even there is laboratory, even in the mines itself, to take care of it. And one of the major challenges is how to control the particle size distribution as far as the grinding of cement is concerned. So we have various combinations at the plant manufacturing stage itself. There is a combination of ball mill and roller press, and you have VRM as well as roller press finish. So you can have a combination and permutations and combination of various grinding media, so that grinding aids, so that what happens is, just not being confined to fineness of cement, we also need to look at the particle size distribution, which is very critical. So we are able to bring out that. Cross-belt analyzer to analyze the raw material which is coming into the cement manufacturing process. An online analysis is being done, which helps us to control the quality of cement. The limestone stacker and reclaimer, which is there in our cement plants. Various product range. Of course, the largest selling brand is within our this thing is the Ramco Super Grade, the Portland Pozzolana cement. We are also having a slag cement, which we basically the sulfate resisting Portland cement, the rapid hardening Portland cement for precast elements and components. We also have a dry mix plant at Chennai, where what we do is that we study the behavior of a cement in concrete. This is a kind of this thing where we could understand technology from Germany, from MTech Germany, and we have been able to manufacture a wide array of products ranging from Ramco Super Plaster, Ramco Super Fine, the wall putty, and the tile fix, which we have been able to cater to various project personnel, so that they can fix various kinds of tiles. What we are doing here is the various kind of adhesion strength that we could give, even within a thickness of 3 mm of tile fix that is being laid, the block fix, the tile grout, the various kinds of tile grouts that we are manufacturing from our dry mix, the self-curing plaster, because what is more important is the challenge is how do we ensure curing. So we looked at that problem, and we are trying to see how we can overcome that. So we have brought in the self-curing plaster, which takes care of various common problems, especially the hairline cracks, and especially the need to do away with curing, which are things like, say, for example, hacking. Can we do away with hacking? So can we develop a product which can do away with hacking? So it is in this aspect we have been able to develop this particular product which is able to give a grip to the plaster, both in terms of chemical as well as the physical grip that is given when we apply this product on the ceiling. And of course, we have a lot of joint works there in collaboration with them. So thank you so much for having given us this opportunity by Indian Concrete Institute, and we look forward for many such interactions. Thanks a lot.
Thank you. May I request Dr. Ashwath to kindly hand over a bouquet. Representative from Fisher to make their presentation.
So, good morning everyone. My name is Edward. I'm from the Technical Manager for Fisher India in South. First of all, thank you so much for this opportunity. We are very happy to be here and to be associated with ICI here. Thank you again. Fisher as a company was started in 1948 by our founder, Mr. Arthur Fisher. In terms of major landmark, we are one of the global leaders in these anchor fasteners. Apart from that, in 1993, we took over the company called Upart, who were manufacturers in chemicals, and that got us into the chemical market. We came in with the epoxies and the vinyl esters and gave us the next major landmine was in 2017 when Fisher started its own subsidiary here in India in January of 2017. At Germany, we have 4 major plants. The first one being in Chimlingen is our headquarters. We manufacture our nylon plugs and steel anchors there. The second plant is at Hob, where we manufacture kinematic components. These are systems for them. The third plant that we have is at Freiburg, where we manufacture our mechanical steel anchors. And the fourth plant is in Denzling, where we manufacture our chemicals. In terms of manufacturing, we have 9 manufacturing plants across the globe. And in terms of sales, we have Fox. Why Fisher? One of the first things that comes to when we talk about anchor fastening is approvals, the ETA approvals, ICC approvals, fire resistance approvals. So Fisher as a company, we are able to support you with approvals and all the other data in terms of design. Associated with various Indian projects. It is metro projects across India. We have worked with the likes of NPCIL, the ONGC for MRPL, and designs. So we support with anchor and rebar designs. And since these are done on a theoretical factor, we also support with pull-out tests done at site. Connecting a shear connector to a shear connectors on a retaining wall from the rock. Then we have a raft of footing. The last picture is something we see at almost every site. There's curing water lying around and rebarring needs to be done. The Fisher's product offering for this application is a product called FIS-EM. EM stands for epoxy mortar. Just to bars ranging from 8 dia to 40 dia, and for anchoring from 8 dia to 30 dia. Apart also for rock anchoring applications and hammer drill or core drill dia holes. Another thing that you can notice here is the curing time. The first one is the working time, which is about 7 minutes. Then we have the curing time, which is about 5 minutes for the product. Where we are using 16, 20, and 25 dia rebars for column and beam strengthening, introducing this application. Of course, used for a smaller dia range from 8 dia to 25 dia. It has been, it is also called the universal chemical because it can be used for both cracked concrete, non-cracked concrete, and even in masonry. And we have ETA approvals for all 3 applications. Another application that I would like to bring to your notice is in terms of fixing of ISMCs, even for crash barriers. The product we have at offer here is RM2, which is a capsule chemical that is available with us. It can be used for diameters from 8 to 24 dia. One of the major advantages of the system being when it becomes an ideal product. There is no wastage. The capsule can be installed directly, And it can be loaded within the first 15 mechanical anchors. The first application that I would especially like to bring to your notice is in terms of the base plate fixing for mezzanine. They work, it's not that they don't work. The only challenge being because the high shear load capacity requirement, the load bearing capacity of stud anchors is lower. What we have is a sleeve anchor, which is called the FH2, shear increase. So these are anchors that are used more for applications where you have high shear load conditions. In terms of approvals, of course, we have approvals for cracked, non-cracked, even for seismic applications. And one of the things that I would also like to bring to your notice is the fire resistance classification R120. So this, again, we are talking about safety when it is in place, not something which gives away. So we have the fire resistance classification as well in this case. These are some more applications where we are talking about we have a couple of stud anchors that are available with us. The first one being FAZ2. This particular anchor has got approval for both cracked and non-cracked concrete, and also for the fire resistance classification and for seismic applications as well. Similarly, we have only a stud anchor with a non-cracked concrete approval only, and can be used for all the same applications. This is a small line. So anyone with academic interest or with interest of designing anchors can get in touch with us. We'll share the link with you, and you can install it at your end and use it and understand the nitty-gritties. Just to bring your notice into a couple of new product lines that we have introduced here in India. The first one being passive fire protection systems. Why is fire so important? There is a fire incident happening across the globe, somewhere across every year, 15,000 civilian deaths. And over 43% of the companies hit by big fires are never operational ever again. System, which is the, we have the detection system and the suppression system in all our buildings. We see sprinkler alarms, smoke alarms, sprinklers, everything. These are detection systems and suppression systems ensuring the fire does not mitigate, but they are these need an external energy source to get activated. What we are talking about is containment. These are systems, once installed, they stay there for the building's life and activate only in case of a fire incident. Otherwise, they stay in place as it is. We are creating a containment where, in case of a fire, the fire is contained within the place of origin and does not get mitigated outside into the next area. The fire or the smoke does not move into the next area. Hence, giving us time to rescue the people. The second one we are showing about horizontal compartmentation. So these are the different areas in a building that we come across in any building. We can have the top of all joints, cavity back, small openings which can create a hazard in an incident of fire because smoke travels at almost 30 meters per second. So this becomes critical. One of the things that we talk about is wherever we may be, whichever part of the globe, we may have various regulations and everything in place. But end idea is simple, that the life safety of the occupant and those nearby. So life safety is what we talk about no matter what codes we are talking about. And then towards the final product line that we have at offer, we've also introduced MEP support systems. We deal with channels, pipe clamps and other product lines where we can support you with designs and also with trainings and applications at site.
Request you to conclude, please.
Yeah. So here we have the steel is got, they cut it, they weld it, they primer it, and all these applications are done. And these are the conventional systems that are traditionally being followed. What we have at offer is something very simple and very neat in terms of application. You can see this, I have some more pictures just to show you. You can see some of the applications. Of course, this is an industrial plant. This is for a commercial. Some more application pictures. So advantages being installation is fast and efficient with the modular Fisher system. There's no welding system. So in case of any change of design or any change of requirement, these can be just removed. The bolts can be just removed and changed, and the entire thing can be redone. These are some of the product pictures and the pipe clamps that we have at offer. With that, I would like to thank you so much for your time, and thank you so much.
Thank you. I request Mesh B. Rao to kindly hand over a bouquet to Mrs. Fisher has got a demonstration, so we do not want to extend till 3. I now request the representative from Trimble to make their presentation. Sir, you have.
Thank you for allowing us to be here. Information about construction, leading organization into the design and construction software solutions. Very quickly, I think when I'm talking about information, I'm sure most of you would have seen this chart, that how basically information flow dips at every stage when we require the detail. So the concept of a new design methodology is erupting, which is a building information model, but we are talking not about the building an information model, but beyond that. So that is silos is what required. So what is the difference Trimble is trying to bring into the overall design phase? You can look at these two pictures, left and right. Both are of the same model, a very crude representation. However, the difference is simple engineering model may not be sufficient to start the construction, and the contractor or the fabricator at our software solutions allows you to build the level of details of the highest degrees. What is the philosophy? We are traditionally, construction and manufacturing are two different industries. They two differently drive the country's economy. However, there is always a competition between these two segments, but now it is narrowing down. Even the construction is moving towards manufacturing, and that is where the precast construction is coming into the picture. And we basically support this entire life cycle, which fully on the construction side, rather than only supporting the design phase of the construction. So our ecosystem, if you look at like the contractors who are into planning, have a full tight integration with. If I just give a glimpse of the two primary industries in the concrete side, I'm not touching the steel. It's cast-in-place concrete and the precast concrete construction. If you look at cast-in-place, what exactly is required? How much of these items do I need? That is one level information. We require the drawing, that how do I fabricate and where do I need to place them? We need the quarterback, that how have I ordered those items? Have they arrived? Or how much material did I use from the material which has arrived? So it is primarily not only about managing the engineering information, it is primarily managing the site, it is the construction. When the construction is taking place, we manage this life cycle. So as I said, managing the information is the biggest challenge. When we talk about the affordability, cost effectiveness, I think if we are able to bring this information in a timely manner, reduce going down, because if whatever I've seen in my career, I think the design still plays an important role, but from the cost perspective, it is still a very minuscule percentage of money which impacts the overall cost. I think the cost is primarily needs to be controlled in terms of labor, equipment, machinery, material, all of that. And so there is a lot in the overall life cycle which we can take away from it. My simple messaging from the software fraternity perspective, like if we are sitting here from the designing side, transferring the information from the design level to the site level, and the concept of modeling, planning, and pouring needs to be synchronized rather than we just focus on creating a 3D model will fear. And We have a booth outside in the exhibit hall. Please do visit if you need any more information, any detailed information. Thank you, organizers.
Thank you. And may I now request 1 minute, sir. Dr. Ashwath. Tea is served on the in the dining hall, but please make it a point to come back as early as possible. I'll be shortening the tea break only to 20 minutes.
Hello? 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 Check, check. 3 ನಂಬರ್ ಕೊಟ್ಟಿದ್ದೀನಿ, ಇನ್ನೊಂದು 1ನೇ ನಂಬರ್ ಕೊಟ್ಟಿದ್ದೀನಿ. ಚೆಕ್, ಫೈಬರಲ್ಲಿ. ಹಲೋ? ಚೆಕ್, ಹಲೋ? ಹಾಂ.